spectrometry is a way that we can modify Dalton's atomic theory, and we did that through the identification of isotopes, and that's around the early part of the 1900s. Isotopes, remember, are going to be the same element, but they're going to have a different mass, and that's based on the number of neutrons that they have. And what we can do from that is we can eventually calculate the average atomic mass, and that's going to be on the periodic table. It's sometimes referred to as the atomic weight. Now, also mass spectrometry can be used to look at individual atoms, elements in a sample, and we can even break apart big macromolecules and look at the fragments that are found within that, or molecules within. And so if we look at a basic mass spectroscope, what we're going to see are three parts. We're going to have an ionizer, a mass analyzer, and then a detector. And so let's look inside the ionizer. What are we going to find? Well, the first thing we're going to find is it's a total vacuum. In other words, this doesn't work unless we remove all of the gas particles that are found inside the mass spec. Next thing we're going to do is we're going to insert our sample in. That could be a solid, it could be a liquid, it could be a gas, but we're going to inject it into this ionizing tube, and then we're going to hit it with electrons. And so we're going to move electrons through the sample. And so there's a little cathode ray tube. It produces all these electrons. And what it's going to do is it's going to pull electrons away from the sample. And then as it does that, it's going to create a number of positive ions. And so we're going to ionize that sample inside here. Remember, it's still the sample, it's just ionized. It's lost its electrons. And so now we move to the mass analyzer. That's really only going to have two parts in it. It's going to have an electrical field. You can see that's negative because we want to move the ions into the mass analyzer. And then we're going to have a magnet. And what that magnet is going to do is it's going to bend the path of the ions. And so as we're bending the path of the ions, it's just like driving around a corner. If you're really heavy, it's harder for you to make a corner. Let's say if you're in a big semi-truck. But if you're in a little motorcycle, it's easier to make it. And so this is where we're going to figure out the difference between the mass of those ions. And then finally, we have a detector. That detector is going to be made up of two things. We're going to have an electron multiplier, which is essentially a plate. As electron hits it, it spawns more electrons, which hit the next plate, which spawns more electrons. And so we can really have a small amount of ions or anything hitting that plate, and we're going to get a signal. Now, that signal has to be amplified, but eventually we can send that into a computer, and we can look at the spectrum coming from those different masses. And so the first thing you have to do is you have to calibrate the machine. What does that mean? You're going to start sending ions through. Okay, so that ion didn't hit the detector. Why is that? It's because the magnet is turned up too high. And so we're going to have to lower the strength of that electromagnet. We run another ion. Okay, now the magnet's not quite strong enough. And so now we run another ion, another ion, another ion. Okay, so we've calibrated it, and so it seems like it's working well. Which of these would be heavier? Well, the ones that are heavier are going to be the ones that can't quite make the corner, and so they're going to end up out here, and then the lighter ions are going to end up right here. Now let's actually get to some sampling. And so this is what it's going to look like when we create a spectrum. We're going to have the different weights across the bottom, and then we're going to have the intensity. And so wherever the intensity is high, we're going to have peaks. That means we have a lot of ions that are with that specific atomic weight. And let's try chlorine. So we're going to put chlorine through here. Chlorine really only has two stable isotopes. It's going to have chlorine 35 and 37. And so let's watch and see what happens as we send this chlorine through the mass spec. Okay, so what did we find? Well, there's really only two types of ions, and so we're having two peaks. Which one is going to be the chlorine 37? Which one's going to be the heavier ion? Well, that's going to be this one right here, because it wasn't bent as much using that magnet. If we look back at that, let's look at those ions flow again. So you can see that chlorine 37 doesn't quite make it around the corner. And which do we have more of? Well, we're going to have more of that atomic, those with an atomic mass of 35.